Hello students, welcome to online course of Mechanical Measurement and Metrology. Myself Abhishek Trivedi from Mechanical Engineering Department at LJ Institute of Engineering and Technology. We are discussing force, torque, pressure, strain and temperature measuring instruments as well as the measuring methods. In the previous lecture, we have started with the concept of the torque. What we have discussed in the previous lecture, we have started with the torque. What do you mean by torque? How the torque will be applicable in the mechanical industries? Then what is the shaft power? The concept of the shaft power. Then we have discussed the brief classification of the torque measuring techniques, or we can say the shaft power measuring techniques. We have classified the torque measuring or the shaft power measuring techniques in the three different categories. The first one, that is the absorption type techniques, the second one, that is the transmission type, and the third one, that is the driving type techniques. All the techniques are totally depends on the construction of the dynamometers. So we have designed the different dynamometers on the basis of the different techniques. In the first one, absorption type dynamometer, we have designed the rope brake, Brownie brake, hydraulic and the eddy current dynamometer. In the second one, transmission type dynamometer, we have designed the basic belt transmission, then the epicyclic gear train dynamometer, and the third one, in the driving type dynamometer, we have designed the electric cradle dynamometer. Then we have started with the basic concept of the Brownie brake dynamometer, how the Brownie brake dynamometer will be helpful in the mechanical industries for the measurement of the power. Till this particular topic we have discussed in the previous lecture. Now we are going to start, or we can say we are going to further discuss the different dynamometers like the rope brake dynamometer, hydraulic dynamometer, eddy current dynamometer, and how it will work in the mechanical industries. So let us start with the concept of the rope brake dynamometer. The concept rope brake dynamometer, as the name suggests, we are using some sort of the rope. The rope will apply the brake and the instrument is known as a dynamometer. The same concept we have discussed in the Brownie brake dynamometer, we are repeating almost same concept with a different aspect. The figure shows the rope brake dynamometer. First of all, let us understand the constructional details of the rope brake dynamometer. We have the spring balance, or we can say we have the spring scale. Then the hook is attached with the spring scale. The rope is attached with the particular dynamometer. Remember this, the rope will move like this. It will directly cover the wheel first. After covering the wheel, then rope will again cross and it will attach with the hook. The hook is there, and below the hook we are providing some sort of the weight. This is the basic concept of the rope brake dynamometer. In many of the dynamometer, we are providing some sort of the wooden blocks over the rope brake to increase the frictional resistance. We are providing some sort of the wooden blocks as well. This is the driving wheel, or we can say the pulley, and inside the driving wheel we are attached with the driving shaft, or we can say the shaft of which the power is to be measured. Suppose in the very first condition the wheel is not attached, or we can say the shaft is not attached, then there might some chance that the wheel will start rotating as a redundant link. So to avoid such sort of the redundant link, we are providing some sort of the dead weight over here. The dead weight, that is a W, let's say W, it shows the dead weight to maintain the proper positioning. Also the weight of this particular dead weight, let's say DW, then the hook, then the rope, the wooden blocks, the weight of this hook, it all shows on the spring scale. It means in the ideal condition the spring scale itself shows some sort of the reading, let's say S1. S1 is the basic reading which is available at the end of the spring scale, which shows the dead weight reading, or which shows the ideal reading which is available if the system is not in use, if the system is not in the operation. We have to provide some sort of the cooling water arrangement over here. The cooling water arrangement is useful for the cooling the particular dynamometer, because as we have already discussed in the earlier dynamometer, that once you start increasing the absorption type dynamometer, it will simply generate the friction, and the friction will directly convert it into the heat. It means you are generating the heat only. And if you are using the rope and you are using the wooden blocks, then it is very much necessary to make a system cool down. So to maintain the temperature, you are using the cooling water arrangement. The cooling water is useful for maintaining the temperature of the system with the predefined standard range. So we are using the cooling water as a basic system to use to cool down our ideal system. Now we are going to start our basic concept. Once the shaft has been attached, it will start rotating in the one direction. Let's say this is the direction of the rotation of the shaft. Once it will start rotating, it will try to skid over the rope and the wooden blocks. It will try to skid over the rope and the wooden blocks, and the rope and the wooden blocks have a tendency to resist the motion. So we can say that if the motion of the shaft is in the clockwise direction, then we can say that the resistance generated due to the rope and the wooden block will be in the anti-clockwise direction. If this one will be the clockwise direction, then now if the weight is not there, then there is a very easy chance that the shaft with high speed will directly skid the rope and it will start moving along the rope. The rope will be steady, it will be slip out, and the shaft will be moving properly. But then you are start to increase the weight. You have started increasing the weight one by one. As the weight will be started increasing, then the whole structure of the rope will start pulling down. We know that this is the position of the rope. The rope will turn the particular wheel and then it will be goes down. So once it will start moving down, then the direct effect of the tension will be generated over the top end of the hook. We know rope is made up of some material, and the material is incompressible material, inextensible material. Then if this is inextensible material, then it is not going to be extended. Then if the rope is not extending itself, then it will start generating the frictional resistance. So by increasing the particular value of the weight, the frictional resistance has been generated. The resistance will be generated over the wheel. The wheel will be start decreasing, or we can say the wheel will be start losing its speed. The speed has been reduced drastically, and once we are increasing the certain amount of the weight, we are supposed to achieve that the speed of the shaft will tends to 0, and after the certain weight it will be 0. Once the speed of the shaft will become 0, we can say that the wheel will automatically stop down, and whatever the resistance generated, whatever the reaction generated inside the wheel, we are simply not down those particular reaction, and by multiplying it with the radius of the wheel, then we can easily calculate the torque, or we can say the shaft power generated inside the wheel which is attached to the wheel. Once the speed will be 0, we are supposed to find some sort of the value, let's say S2. Then what we are using to find the total force applied over it, we are simply doing S2 minus S1, because S1, that is the dead weight condition, which is not calculated once you are measuring the power, once you start to measure the shaft power. So this is the basic case of the rope brake dynamometer. The figure shows the basic structure of the rope brake dynamometer which we are using in the academic institutes. The particular rope has been extended. It is attached with the one spring scale, or we can say one spring, and on the opposite side we are using the dead weight. Different dead weights are provided over here, and the rope will be turned through the particular wheel. Once the wheel will be started moving, let's say in the particular direction, once it will achieve some sort of the speed, we are start to increase the weight over here, and as we are increasing the weight, the speed of the wheel will be reduced step by step, and once in a time it will be reduced to the 0, and once it will be reduced to 0, we are simply calculating the weight which is applied over the end of the hook, and we are simply calculating the torque, and we are simply calculating the rotational power, or we can say the shaft power which is available at the end of the engine shaft. So this is the basic concept of measurement of the power. The rope brake dynamometer is highly useful for the measurement of the engine shaft power. In the laboratory, if we are supposed to check, or if we are supposed to find the power available at the end of the engine of the 4-stroke 4-cylinder, 2-stroke 4-cylinder engine, then we are using some sort of the rope brake dynamometer. It is widely useful in the automobile industries for the measurement of the power. Then the next one, that is the hydraulic dynamometer. As the name suggests, hydraulic dynamometer is directly concerned with the hydraulic system. Dynamometer, this is also the case of the absorption type dynamometer. So here again we are try to reduce the speed of the shaft, and once we are achieving our goal, the shaft speed will be 0, and whatever the resistance has been generated, we are simply calculating the resistance and we are simply calculating the force. In the particular hydraulic dynamometer, first of all understand the constructional details. This is the center shaft, or we can say the main shaft, which we have to check. The shaft is directly attached with the rotor. I am making a red hatching portion. This is the rotor which is directly attached to the shaft. So I can say that as the shaft will start rotating, the rotor itself will also start rotating inside the chamber. Beside the rotors we have the stator, the outer body. This is the outer body. The whole outer body shows the stator concept. This is the stator. Between the rotor and the stator we have the cavities like this. This is also the cavities. This is also the cavities. So if we are going to change the color of the pen, you can check the cavities. You can check over here. This is the cavity number 1, cavity number 2, cavity number 3 and 4. What we are doing? We are simply providing the oil, or we can say we are simply providing the liquid inside the system. In the ideal case, the rotor is steady, shaft is not rotating, the oil will be filled inside the cavities, the oil will be filled inside the whole setup. You can check, this is the piping has been provided. The piping will shows that the oil will be getting filled over the whole setup. Done. So in the initial case, the oil has been filled properly. Once the rotor will start moving, once the shaft will start getting its original speed, after the getting its proper speed, the rotor will also move with the same speed. But due to this cavity, some sort of the vortices has been generated, some sort of the vortex has been generated. Vortex. The external rotational motion has been generated inside the fluid is known as a vortex. The vortex shows some sort of the resistance. So once the vortex has been generated, due to some external forces, the rotational motion will generate inside the fluid is known as a vortex, and the vortex will be generated. It will directly create some sort of the resistance to the motion of the rotor, and slowly and steadily the motion of the rotor will be slowed down. The speed of the rotor will be slightly start decreasing, and it will be directly attached with the main shaft. So we can say that due to the vortex, due to the resistance of the vortex, the main shaft speed will slightly started decreasing its original speed. So just because of that, the shaft will be losing its speed, and some sort of the friction has been generated. The friction is generated due to the vortex flow. So this particular friction is known as the vortex friction or vortice friction, and just because of this vortice friction, the shaft will losing its speed and it will tends to move to 0 value. And once it will achieve the value of 0, then we are simply calculating the vortex friction, and by checking the distance at which the friction has been generated, we are simply calculating the power which is generated at the main shaft setup. The next one, that is the eddy current dynamometer. As the name suggests, once again we are using the eddy current as a basic core concept, and dynamometer is an absorption type dynamometer, so there might some chance that the speed of the shaft will be getting 0. Now first of all understand what is the basic concept of the eddy current. Eddy current is a form of loss. If you have a magnetic setup, or we can say if you have the electromagnet, by using the battery supply you are supposed to generate the electromagnet, it will generate its own magnetic field. Suppose this is the magnetic field. Generated by the electromagnet. Suppose this is the direction of the magnetic field. two poles has been generated. If a connecting material, or we can say if a conducting material will come into the picture, and if it will cut the magnetic field slightly, then again the particular conductor will also perform as a magnet itself, having the lesser magnetic value than the prior one, but it will also perform as a different magnet. So what is happening? Suppose a conductor will cut the magnetic flux, then suppose this is the flow of the magnetic field, this is the direction of the flow of the magnetic field. The conductor itself generate a closed loop which is opposite to the flow of the magnetic field. So we can say that if the conductor will come in the picture, then it will directly generate the opposite flow. The opposite flow will oppose the motion of the electromagnet from cutting the magnetic flux. Now how the eddy current will work? The same way, the rotor has been attached to the main shaft, the stator has been provided. Here we are supposed to provide some sort of the electricity, it will generate some sort of the electromagnetic flux, electromagnetic field. The stator generates its own electromagnetic field. The field coil has been provided inside the chamber of the stator. Once the rotor will start moving, the rotor will continuously cutting the magnetic flux, or we can say the rotor will continuously cutting the magnetic field, and due to this particular arrangement, the rotor will itself work as a conductor and it will generate the closed loop. The closed loop is opposite to the basic loop, or we can say basic flow of the magnetic flux, and due to this opposition of the closed loop, some sort of the eddy current has been generated, and this eddy current will resist the motion of the rotor, because it will try to hold the conductor, it will try to hold the conducting material to be inside the permanent magnetic field. But due to the rotation of the rotor will not stand inside the, or we can say the rotor will not hold its position inside the magnetic flux. So the eddy current will try to stop down the rotor and to make it in the permanent position inside the magnetic field. So it will resist the rotation of the rotor, and the rotor will start decreasing its original speed. And as we have already discussed that the rotor will directly attach to the main shaft, so indirectly the main shaft will start losing its original speed, and by the grace of time the main shaft will be achieve the zero speed. Once the main shaft will be achieve the zero speed, we are simply calculating the magnetic flux which is generated and the area over which the flux has been generated, and then we are calculating the shaft power, or we can say the torque which is generated over the shaft. So guys, this is the eddy current dynamometer. Over here we are winding our lecture. What we have discussed the three different dynamometers. The first one, that is the rope brake dynamometer, then we have discussed the hydraulic dynamometer and the eddy current dynamometer. Today this is the end of the topic named as the torque measurement, or we can say the shaft power measurement, or the shaft power measuring instruments. From next lecture we are going to start our third portion of the chapter, that is the strain measurement. It is very useful for the mechanical industries. Till then, thank you.